Epinephrine signaling pathways play a crucial role in the metabolism of glucose. The signaling molecule in this pathway is epinephrine, and the receptor is beta-adrenergic receptor, which is a type of G-coupled protein receptor. To the right of the beta-adrenergic receptor, there are three subunits that play an equally important role in the pathway. These subunits are known as G-alpha, G-beta, and G-gamma subunit. Before the pathway is initiated, there is also a molecule of GDP attached to the G-alpha subunit. When a hormone binds to a beta-adrenergic receptor, epinephrine signaling begins. After binding to the ligand, the epinephrine receptor goes through a conformational change, where the receptor protein changes shape in response to the new external stimulus. After the receptor is activated, a chain reaction occurs, starting with the activation of the G protein. When the G protein attaches to the activated protein receptor, GDP is replaced with GTP on the G-alpha subunit. To the right of the subunits, there is adenylyl cyclase. Adenylyl cyclase is an enzyme that converts ATP molecules into signaling molecules called cyclic AMP. Then, the hormone leaves the receptor and makes the beta-adrenergic receptor inactive. The G protein then moves to adenylyl cyclase, transforming it to its active form. At this point, molecules of ATP are introduced into the pathway. These ATP molecules are then transformed into cyclic AMP by adenylyl cyclase. CAMP is often referred to as a second messenger as it carries on the message of the first messenger, epinephrine.
Next, the G protein disables itself, and the subunits recollect. Adenylyl cyclase becomes inactive and can no longer convert ATP to CAMP. Then, the CAMP molecules continue this chain reaction by binding to protein kinase A. This binding reaction stimulates the enzyme to divide into two catalytic subunits. ATP activates the two inactive subunits. Then, the activated subunits add phosphate groups to an enzyme called phosphorylase kinase. This reaction then activates the enzyme and causes phosphorylase kinase to phosphorylate another enzyme called glycogen phosphorylase. Activated glycogen phosphorylase creates a cellular response to epinephrine, where this activated enzyme breaks down glycogen into glucose molecules. This allows glucose molecules to be transported across the plasma membrane and enter the bloodstream.
Hyperglycemia is the condition in which glucose levels are elevated in the bloodstream, resulting in an increased blood sugar. As seen previously, epinephrine is responsible for the breakdown of glycogen into glucose and its release into the bloodstream. During stressful situations, more epinephrine is made in response to the stimulus, therefore making this condition severely dangerous and sometimes even fatal to those who suffer from it. Hyperglycemia can cause increased thirst, tiredness, blurred vision, weight loss, and recurring infections.